Alright, first I want to start off by explaining that one needs to be aware of the importance of not using the terms moderator and mediator interchangeably. As Barron and Kenny said, moderators and mediators are different in many ways, and researchers and the social scientists most times fail to recognize the difference. A moderator is a qualitative or quantitative variable that affects the direction and or the strength of the relation between an independent or predictor variable and a dependent or criterion variable. In contrast, a variable is said to function as a mediator to the extent that it accounts for the relation between the predictor and the criterion. Mediators explain how external events take on internal psychological significance, whereas moderator variables specify when certain effects will hold, and mediators speak to how or why such effects occur. First, I want to start off by explaining what mediation is when looking at the diagram I have on this slide. It's when we're assessing x predicting y, but the x has to go through this mediator before reaching y, which is important to mention because this is not an interaction but a path decomposition. So for the first mediation analysis, I computed a new y from the dataset by using ny equals y plus rv dot normal, and I chose to use the bootstrapping method over the Sobel test because according to Preacher and Hayes, bootstrapping provides the most powerful, reasonable method of obtaining confidence limits for specific indirect effects. It's also a method that involves repeatedly sampling from the dataset and estimating the indirect effect in each resampled data. Then I ran the linear regression through the process by Andrew Hayes, and the output gave me this coding matrix. For the first outcome variable m, the x coefficient is the relationship between x and m, or the a path. So we can see that this is our coefficient, and it has a significant p-value. And the outcome variable ny, the m value is b, which is the relationship between m and y. And here is the coefficient, and it also has a p-value that is significant. The x coefficient and the outcome variable ny is c prime, which is the relationship between x and y, which is not significant, as you can see here. But c prime doesn't matter according to Barron and Kenny. In Barron and Kenny's 4 steps in establishing mediation, the very first step is to show that the causal variable is correlated with the outcome, or in other words, see if the relationship between x and y, or the c path, is significant. And in order to do that, you have to run a regression analysis. And in the coefficient table here for my regression analysis, you can see that x, or c, is significant at the 0.05 level. So Barron and Kenny's steps 1, 2, and 3 have been met, but when looking at step 4, it says to establish that m completely mediates the x-y relationship, that the effect of x on y should be 0. However, the coefficient for the c path is 1.053, but not 0, but is still statistically significant here. Therefore, according to Barron and Kenny, I can say that even though step 4 is not met, we can conclude that there is at least partial mediation and an indirect effect because 0 is not included in the confidence interval here, and thus we fail to rule out mediation. So for the second mediation analysis, I made a new y and made it equal to x plus rv normal, and this analysis includes 0 here at the confidence interval, which means that there is an indirect effect of x to m to y. However, the outcome variable m and the new y1, which is the b path, is not significant. And the confidence interval for the bootstrapping includes 0, which means that there is no indirect effect, so we rule out mediation. Moderators affect the relationship between x and y, but they also have direct effects but are not temporally bound like mediation models, and they also do not share the same causal structure. So with the data set, I created an x1 and an x2 by using the RV normal function in SPSS, and then I created a dichotomous x2 variable leaving x1 as a continuous variable. That is when I use the checks and x's. I use 0 for the x's and random numbers for the checks to plug into the equation and create a new y that allowed me to duplicate one of the 16 plots for the moderation analyses. And in order to interpret the B3, or the interaction, we have to center the variables, x1 and then x2, the dichotomous variable. And then multiply the two centered variables by each other to get the interaction variable, and then run a regression analysis with the appropriate y in centered x1 and the centered x2 dichotomous variable. So in the first analysis, I chose to use check x check check, where b0 is significant because the intercept is not a 0, where b1 is not significant because the slope is 0, and b2 is significant because the intercept originates at different points on the y-axis when compared to b0. And b3 is significant because the slope is not 0, thus is significant. So after running the regression analysis, we can see that the centered x1 and the centered x2 dichotomous variable, as well as their interaction, are all significant. In the second analysis for moderation, I chose to use check x, where b0 is significant because the intercept is not at 0. b1 is not significant because the slope is 0, where b2 is significant because the intercepts originate at different points on the y-axis, and b3 is not significant because both slopes are equal to 0 and are non-significant. So after running the regression analysis, we can see that the p-value for centered x1 is not significant, and the dichotomous variable x2 is significant, and the interaction overall is non-significant, which is exactly what I expected given this scatter plot. For the third analysis, I chose to use check x, where b0 is significant because the intercept is not at 0, where b1 is significant because both lines have the same slope, where b2 is significant because the intercepts originate at different points on the y-axis, and also b3 is not significant because the lines have the same slope and therefore there is no interaction. So after running the regression analysis, we can see that the p-value for the centered x1 is significant and the dichotomous variable x2 is also significant, but the interaction is non-significant, which is exactly what I expected and is shown in this graph. That's all I have for this Module 2. Hope you have fun listening. Thank you.